in this brief video, I will explain the 4 addition reactions in alkynes. Remember that alkynes have at least one triple bond. As we had in alkenes, we will have symmetrical additions. We will have this symmetrical, and the 2 symmetrical additions will be hydrogenation, when I add hydrogen, but in this case all these reactions will happen in 2 steps. For this one, the partial hydrogenation is when I add 1 hydrogen molecule. This will break one of the multiple bonds, and in this first step what I will get is an alkene with a double bond. This is step 1. And then in step 2 I have the hydrogenation of an alkene that will give me an alkane. The mechanism is the same. The double bond is broken, and then 1 hydrogen comes here, the other hydrogen comes here. It's the same for this one. The hydrogen comes here and the other one comes here, and at the end I will have an alkane. If I want to summarize this reaction, okay, I will call this one partial, and if I want to summarize the reaction, what I will have is the alkene molecule, let's name it total, I will have the alkyne molecule that will react with 2 hydrogen molecules, and it will become an alkane. Okay? This is like the summary for hydrogenations in an alkyne with a triple bond. The second symmetrical addition is halogenation. And again, we will have 2 steps. In the first step, the alkyne with its triple bond will combine with a molecule of any halogen. Let's use chlorine. And here, as this is symmetrical, one of the multiple bonds will break. It will open. Oh, these are supposed to be arrows. 1 chlorine will come here. The other chlorine will come here. And what we will have as a result is an alkene with 2 chlorines. 1 chlorine will go here, and the other chlorine will go here. In the second step, the alkene with 2 chlorines will react with another chlorine molecule, or bromine, or fluorine, or iodine, to give you a tetrahalogen alkane. We will have 2 chlorines here and 2 chlorines here, because again the double bond breaks, it opens to the 2 carbons. One of the chlorines comes here and the other chlorine comes here. We can also call the first one the partial halogenation of an alkyne. This is partial. And if I want to summarize the total, it will be the molecule of the alkyne that will react with two halogen molecules to give a tetrahalogenated alkane. Here we have the 4 chlorines or bromines or iodines or whatever you want. This is the summary. And as you can notice, it's very similar to the reactions in alkenes. Then we have the asymmetrical reactions. The first one, okay, let's continue. These are asymmetrical additions. And here we have, the first one will be hydrohalogenation. In this one, I will add a hydrocide. Remember that the X may be any of the halogens. Again, we will have two phases. In phase 1, the alkyne with its triple bond will react with the HX molecule. Let's use bromine here. And if there is no other instruction, it will follow the Markovnikov's rule. Again, the triple bond in this case will break. And here, hydrogen will go to the carbon with more hydrogens. Bromine will go to the carbon with less hydrogens. So in the first step, what we will have is an alkene with the bromine here. Okay? And the hydrogen will go here. We will not draw it, but it goes here. Okay, this is a hydrogen. In the second step, my alkene with the bromine will react with another hydrobromic molecule. Again, the double bond breaks, and each electron goes to one of the carbons. And again, the hydrogen comes where we have more hydrogens, and the bromine will come to the carbon with less hydrogens, where the double bond was. So as a result, we have an alkane with the two bromines in the same carbon. This will be the result here. If we have an anti-Markovnikov hydrohalogenation, we can add some substances as catalyst to make the reaction happen in a different way. And let me put it here. It will be A1 anti-Markovnikov hydrohalogenation. And it should be indicated in the question. What will happen here is that we start with the alkyne with HI, let's use hydroiodic acid now. In the first step, one of the bonds breaks, but now the hydrogen will go to the carbon with less hydrogens, that is this one, and iodine will come here. The first product will be an alkane with iodine or the halogen in this carbon. This is the partial reaction. In the second step, I will start with the alkene, another HI molecule. Here we're going to break the double bond. This electron goes here, this one goes here. Here, as it is anti-Markovnikov, the other molecule of iodine, or the other atom of iodine, will go to the opposite carbon, and the hydrogen will come here. So the result will be an alkane with two halogens in the two different carbons, like this. The hydrogen, the new hydrogen will come here, and then we will have this kind of alkane, sorry. In this case, the catalyst for the anti-Markovnikov reaction will be peroxides that will be represented like this. Don't worry about this. Just remember that this is a peroxide and will make the reaction to happen in the opposite direction. And the last addition, okay, let me go back. One is hydrogenation. The last addition we have for alkynes will be hydration with water. The first step is very similar to the one in alkenes. I have the alkyne here with a triple bond, a water molecule that I can represent like this. This bond breaks. Okay, let's break this bond, open it. Again, the hydrogen goes where we have more hydrogens. The OH will come here. And what I will get is an enol, an alcohol with a double bond. Here it is, the OH. But here there is not a second step for another water molecule. This enol is a very unstable molecule. This is the enol, and it is very unstable. What will happen almost immediately, oh, this is too big, is that this enol will be transformed in a ketone. This is something like this. And this will be the final product. This is a ketone. What happens here, the reaction is a little reversible. What happens here is that this double bond will break, this will come here, this will come here, and the hydrogen will move to this carbon to get the ketone. So in hydration, there is no second step to add a new water molecule. The enol that results from the first step will immediately become a ketone. And this is the last addition reaction for alkynes. We are not going to see ozonolysis for this.